right, this is the video for this saw. I'm showing you the build, the whole process of the build, all the way up through to the first couple of cuts. It's just the first couple of cuts. We'll do a dedicated video to the full cutting session. So if you're not into watching the boring machine shop and porting and all that stuff, then this is not the video for you. You'll want to wait until I get the video together for the full cutting session, because I literally made like 3 or 4 cookies, and that's what you're going to see at the end of this video. So it is not 100%, but it's, you know, it's running pretty good. But yeah, you're going to get to see the whole thing, and she's going to be a long video, I bet. So there you go. Now this video took me upwards, I don't know, maybe a month to make, maybe 3 weeks, I don't know. So hope you appreciate it. She took a lot of patience. This could have easily been 10 different videos that I kind of clipped together and turned into one a little bit longer video. So let me know if you like this style format or build video showing the whole, all the way up to the process to the first cuts, or if you'd rather see them broke apart with more details in each part. It's either going to be one or the other. You tell me what you prefer. So as you can see, I got a little bit of a clutter on the bench. It's because we're working on 2 of them. So back here is the wild thing. We got her kind of disassembled there. And I'm doing some intake work. You can see some JB weld there, some JB weld there. I'll give you more details on that as I get further along. But yes, we're going to try to do a pretty hefty modification of the intake. The other one here is a 372. This is a big bore 372. And I'm getting ready to start doing the chamber cut. This is Dino Joe, the Dino Joe chamber cutting tool. That's pretty much what I use exclusively for chamber work. That and sandpaper. So everything you see me doing is pretty much coming off of that there thing. And I'm getting her set up right now to start it. And I'm curious because this plating in here is it looks pretty rough. I don't know if this tool is going to be able to get through it. I might have to sand that out. We'll find out here soon enough though. All right, so about to work on the combustion chamber. Here's what she's looking like right now. Pretty typical finish for the chamber cutter tool. But you can see it's a drastic difference. Now that's a bit of a wider one. Some folks might be like, yeah, that's pretty wide. I think, so I cut it into a taper. And I think because it's in a taper, it made it a little wider. And I'm actually pretty happy with that. So next will be to do the piston. Because I cut it into a taper, I have to match it with the piston. I have to match that taper. So that's next on the agenda, and then after that we'll be throwing the piston in here and cleaning everything up with sandpaper. All right, I think I got you zoomed in here pretty good. So we're going to start cutting the taper into the piston. So this socket is our guide. You're going to see it kind of come in, almost looks like a pop-up. The size of the center is there. So if we were cutting a pop-up, we would want the pop-up to be just ever so slightly smaller than this socket. And then we could cut our pop-up. I don't know if I'm going to cut a pop-up into it. I might not. But let's go ahead and get started here. All right, so the next step in our process here is to do the sandpaper. So basically all I do is I stick sandpaper to the top of the piston, I send it on up in there, and I hook this little guy up to a drill. I shove it down there and I spin it. Now a lot of guys have actually made tools to go in there where the wrist pin goes. That way you have it nice and center. I need to do that. I haven't done it yet. I definitely need to do it. For now, this works just fine. All right, that's as far as I'm going to take it. So I want to show you something. See the scratches? That's an indicator of just how well they chamfer the ports from the factory. Just by spinning the piston in there, I got all these scratches. You know what I mean? The worst one would be up where the compression release is. So I don't think they cut any chamfer into that one, and it's definitely left the worst scratches here. But something to think about there, factory chamfers, you know. It'll scratch up the piston just by me spinning it. It'll scratch it up by going up and down. You know what I mean? But there she is. There's our chamber cut, done, ready to go. So now we get to move into the depth. And the next step is setting our squish or the porting. There's, you know, either one of those. We could do the squish or the porting next. All right, we're on another day here, and I'm going to start working on getting my squish set. I just got the wrist pin in the piston. I'm getting ready to put it on so that I can start working on the squish stopper. These are my safety glasses, my cheaters. I'm finding myself using them more and more just to see. January, I have an eye appointment in January, so let's see if I end up with full-time glasses or just something I need when reading. I'm kind of curious. I bought this thing a while ago to help keep me from getting so greasy, and I've only used it a few times. I'm tired of all my clothes being so greasy and nasty looking. My bench, the end of it right here, I need to clean it. It's kind of filthy. All I gotta do is get near it and I get dirty. Now I need to throw some bolts in this cylinder to figure out what our first goal is here on our chamber cut. First cut's gonna be the biggest one. Then we're gonna fine tune it. All right, so first we're gonna start off with a piece of solder wire. This wire is 60 thousandths, so if we don't make contact, which I don't think we will, we know we're past 60 thousandths. Then, yeah, it's not even close. So we're just gonna get a rough idea here. What I'm gonna do is I'm gonna twist this. So now I twisted a piece up on the end to make it a bit thicker. Let's see if that makes contact. All right, that didn't even make contact. All right, I twisted up a fatter one. I added like another strand in there and twisted it up a little fatter. I think we're real close. Not enough to squeeze it though. All right, I hope this angle works for you. I don't really have anywhere I could put the camera closer without really moving everything, so I just got you zoomed into the max. So hopefully you get to see it well enough. I gotta take care of this real quick. That play, that's common with these type, or with these lathes. You'll see here in a second. There's a screw. There's 4 screws here. I'm just gonna kind of give them a little snug here. Start. So what we're gonna do is we're gonna mark right here. And I learned this from Briscoe. He told me to do this. Take a base measurement right here. This is just our rough cut, our first rough cut. So we're just going to take a quick measurement right there, which is, say, 25. I'm going to put it right here. I'm going to change that. I'm going to put it right here, dead center of where the bolt would be. We're at 20. Okay, 20 thou, which would be 120 thou. So we got a bit of cutting to do. So let's go ahead and get started. I got her all set up, ready to go. All right, so that's exactly 80 thousandths taken off. We figured we needed to take, over 100. So what that's going to do is that's going to set us up to where when we use our solder, we'll, instead of having that twist in it, we'll be able to get a much more accurate measurement from this point on. But before we go back over there, we've already removed enough that the bottom part of the skirt is going to hit when we try to set the cylinder on there. So we need to start shaving some off. And I'm just going to probably aim for about 100 thousandths. Can you see this line? I just did like a little cleanup line, right, like a little cleanup pass right there. You see that line? I need to take about half of that off, this part here. So let's go ahead and get that done. All right, I'm pretty happy with that. I made a pass over this area just to clean it up. No, there's no real reason to do that. I just did it to work at cleaning it up. That's all. But now we're ready to start thinking about putting this back on to get a better squish number. But we've got one more thing to do. So since we just made that cut off the bottom here, if we try to stick the piston on here, we're going to have a rough edge and we're going to scratch up the piston. So I'm just going to take a piece of sandpaper here and just kind of hit that edge a little. There she is. Let's stick her on, and I'm going to get a final squish number, and then we'll come back and start cutting some more. All right, so you know how I had a twist in it before that first measurement I took, and it was not accurate. We still have 70 thousandths to go, but I still have a twist in the solder just to get to that 70. So it's not going to get accurate until we can check it without that twist in the solder. All right, so machine work is done. Piston, everything is ready. You can see the sticky residue from the tape on the top of the piston, or from the sticky sandpaper, I should say, on the top of the piston. But I'm going to kind of show you how I'm going to port this. I'm going to do this a little differently than what I've ever done. So one of the things I'm going to do here is this side area, I am going to remove this. The reason I'm going to remove it is to allow air access or fuel access to this area of the piston. So when I'm at bottom dead center, when we're at bottom dead center, this is kind of how she looks. All right. And you'd think leaving that there would help with performance. Well, my goal is to open this up so that it allows access for fuel to kind of get into this area. I'm hoping it helps to keep the wrist pin area cool. That's the purpose of me doing that. Is just allow access to where air could get in there and try to keep it cool. All right, because some of the work I did here is going to make things hot. So I want to do some stuff here to help keep it cool. And I don't know if it's going to work, but that's what I'm going to do. And let me get her cut out and I'll show you. All right, so that's what she looks like. This cut out. And if I drop this bottom dead center, you can see now we have access to that area. And I'm hoping that by having that access to that area, we kind of help promote keep it cool. But I mean, now I have a pocket here that I might be able to utilize that to gain power. So that's kind of where we're headed. But first, I'm going to work on the lower. All right, so I just changed out to a smaller bit here. And I'm getting ready to work in the lowers. But here's something to remember. if you're looking to gain power in the top, the high RPM range, not really gain power, but to help hold torque in the upper RPM range, never work on the intake side of your transfer or in the lower. Just work on the port match. As long as your port match is good, don't really remove much material here. All you want to do on the exhaust side. So what my goal here is we got a flow headed this general direction, and my goal is to kind of turn it a little more towards the intake. And that's why I don't want to remove it here. I want to remove it from the bridge and cut this all the way back to help promote the flow in that general direction. That's my goal. I'm going to do the same thing with this side here. I'm going to remove the material from this side only to help promote the charge to go in that direction. All right, so now you got kind of an idea. I got it roughed in. You can see compared this side here to this side here, I removed the material from this side of the bridge, not really from this side. I did a little bit just to kind of help smooth it out some, but my main focus was on this side. And that should help promote the flow in that general direction. I'm aiming everything towards the intake side. Now I gotta match this side up to this side. I forgot to mention this. First time I've dealt with this. This is the first time I've done a big bore 372. And I ran into clearance issues with the flywheel. Flywheel was hitting after all that machine work, so I had to do a little clearance work. So now we're gonna start doing some intake work. We're not gonna do anything to the lower side. So this is upside down. We're not gonna do anything to this side. We're only gonna do this side. And we're gonna kind of put a little, they call it lung, kind of a kidney shape, whatever. We're gonna kind of do that here to the intake side. You'll see it here in a minute. There is what I'm talking about. It's kind of like the kidney bean or lung or whatever at the intake. That's what we did there. And if you're looking through it from this side, you can see it nice and big. Now, we got two things left to do. Three things. We're gonna do a little tiny bit of work to the upper. Not much, very little, but we're not ready for that yet. We're gonna do this saw with bridge ports. There's bridge ports and there's finger ports. So finger ports usually get cut in on right above the intake. You kind of cut it in and you run a little finger down and into the bottom part here at the lower transfer. You just kind of cut it and kind of weave it on over and all that stuff. You can see I don't have a whole lot of room here because of what I did here at the intake. And my plan was to actually use a bridge port anyway. And bridge is whenever you run an extra piece from the lower to the upper. So you cut it in here at the upper and you literally bridge the two sections together. But you can really play with the shape of this part of the upper whenever you do bridge ports. This is the style I use mostly. Some saws have fingers, some saws have bridge, and it's rare that I use a traditional boost port. So the bridge port is what we're doing here today, and I'm gonna work it laying it out so you can see what I'm talking about. But one of the things I wanted to mention here is, remember how I said we were opening up this area? Okay, once I cut my bridge in there, it's going to be able to draw from this area of the transfer because of this opening, and that's the plan. All right, so I did a little Sharpie work to kind of give you an idea what I'm talking about there, of how I'm going to bridge it between the lower and the upper. And remember, I'm going to have a nice big opening down here to help capture energy. Then I'm going to send it right up through that upper, going on up. That's what we're getting ready to work on. This takes a little time, takes a little practice to get this just right. Okay, so I kind of got this one roughed in. See that? See how she looks? That's a little wild there, huh? A lot of folks don't do that kind of stuff, but we're getting a little wild and crazy with this. It's gonna have a little higher roof. I'm planning on a 96 roof, and that's why you're seeing stuff like this. So still gotta do the other side, but let's go ahead and get started roughing in the other side. Now we have to start getting our timing numbers. So before I get into any upper work, I want to know what my timing is, and I want to get the exhaust set and all that stuff. So now we got to start working on the numbers. I didn't do anything to the bottom of the intake. I'm just doing everything through transfer and exhaust, really, as far as the numbers go. So that's what I got to do next. All right, so you can see I got some lines marked out. I don't always play with the uppers. This one's sitting at 135 degrees at the uppers, so I am going to do a little tweaking. I got my lucky dog here ready to go, and let's get in there and work on some uppers. This is not something I usually do. All right, so it's just an evening after work. I came out to work on this a little more. I stripped out the my 90, my lucky dog 90, and that was my last head. So, well, I mean, they come with two heads. Now I got them both stripped out. So I got to figure out how to order more. But I had one of the old cheap Chinese 90s, and I just used it to finish it. It's a big bore cylinder, so I was able to get it in there. It sucked. And there she is. See that ring around the squish band? I scratched it while I was doing, I had my flappy thingy, that little homemade flappy thingy in there, and I ended up getting it onto the squish, the squish band and scratching it. It's just a scratch, so I could go in there and polish it out if I wanted to, but I'm not going to. There's a few little spots, I could make better. Like here's a spot right here by my thumb I could make better. I'm not going to put all that time into it. I'm going to run it like this, Now, the numbers are 96, 124 at the upper, and 83 at the intake. That's the way we're going to send it. The exhaust was widened, but not a whole lot, just a little. Most of the effort went into raising the exhaust. The intake was just where it fell after the machine work. And then, the rest of it I did. But we're going to send it like this. I could always go back and take out more. It's kind of difficult to put more back in, So this is just an evening after work, and that's where we're at right now. Cleaning it and assembling it is next. All right, so she's assembled. We're ready to try to make the first cuts. Ran into an issue at the carburetor. There is a passage drilled from like the metering diaphragm area all the way into the throat of the carb, and which allows fuel. You know what I mean? I guess you can say it's kind of like a governing circuit. But the saw was over fueling the first time I tried to start it, so I JB welded that passage shut. So hopefully now she'll actually tune, because before I couldn't get it to do anything more than a 4-stroke. You know what I mean? So we'll see how she takes off today. I'm not exactly 100% certain the condition of that chain, but I think it's going to be on a little hungry side. We'll see though. It's a 58 gauge setup with a 50 gauge bar. So like I've been working on getting this old wore out bar kind of, I don't know how to explain it, but it's a 50 gauge bar that was wore out. So instead of closing it back down to a 50 gauge, it was wore out enough that a 58 gauge chain would go in it, but it's a bit snug. So I'm running it just to kind of get that bar kind of, I don't know, the groove seated or wore out enough for the 58 gauge chain, because I don't know, she seems pretty stable in the cut like this. She's just a little tight. So yeah, we're gonna run that chain setup. I just don't remember how it's sharpened. I don't remember if it's good sharpening or if it was a super hungry sharpening or what. You know what I mean? Because sometimes I play with my chains, and I think that one's on the hungry side. We'll see. The muffler, here's my muffler mod. How do you like that? This used to be on a chainsaw mill. This used to be a mill saw. And I pulled that top end off, put a new top end on it, and ported the new top end. That's what you're seeing here. And that muffler, I was using the stock port, and I had that slot cut in the side. But now I got her opened up like this. I'm missing 2 bolts. They fell out while I was milling. And one of the bolts here, that side bolt for the chain brake, it fell out too. So yeah, this is what she's like. I decided I wanted to do this one and get a different saw for the chainsaw mill. Probably going to be another 372, probably another clone or something for the mill, but I don't have any milling planned for a long time, so I decided to go ahead and build this, and then whenever it comes time to get back onto the mill, I will, you know, replace the saw. You know what I mean? The handlebar will probably have to come off if this works out, because she's not really set up to be a falling saw. So, you know what I mean? Well, I have another handlebar here. I just didn't put it on. You know, I might just get a new one. We'll see. Velocity stack. There is a velocity stack on there and everything. So she's set up. She should run pretty decent. We're going to find out. Alrighty, it's going to be the first cuts out of this saw. We're going to do a dedicated video to this saw, you know what I mean, to the cutting. So these are just going to be a quick couple of cuts for you to see it running and everything, and then we will do a dedicated video really plowing into this saw and seeing if it takes off, if it's turd, all that stuff. You're just getting to see the first couple of cuts. That is a very nice cutting chain. I'm going to take a look and see what I did. I think that's one of the one that I figured out how to make a chain hungry, or I figured out a mistake or whatever that makes chain hungry. I made a mistake. The chain got hungry on me, but man, she cuts like butter. She pulls really hard on the saw though. So that's an 8-pin sprocket on that chain, and you can hear it really pulling the torque out of that saw. Man, this thing would probably be screaming through the roof if it had a normal setup. But it's that 8-pin with that chain combination. This thing really is plowing through that wood. But we're going to do a dedicated video to that. This is just the first couple of cuts out of the saw. I might need to go back into the carburetor. I can't seem to get enough fuel out of it. So blocking off that circuit in the carburetor definitely helped with the control, but now because I'm not getting that flow, it wants more, you know what I mean? So she seems to be a little bit on the lean side, you know. Might have to get back in the carburetor, but there she is. She's running. So she's a longer video. I think it took me 3 or 4 weeks to put this video together for you. So, you know, just clipping little parts of this build together throughout time, you know what I mean, or as the progress went. But there we go, we're up to a running saw now, and now we get to work on tweaking it and, you know, making her making her, you know, sweet. And I can tell you, she's pretty freaking sweet right now. I can already tell. She just wants a little bit more fuel. I got the high speed, ran out pretty far, and she wants a little bit more. So I'm feeling that, you know, a slight little carb mod, and we'll get what we want, you know. She just had this little, like, imagine a hole drilled from the carb body, or from at the metering lever area, all the way through to, where was it? It was coming out near the choke. Was that coming out near the choke or near the throttle butterfly? But I blocked it off. So now 100% of the flow is coming past the jet that I get to control. It's just, she could use just a little bit more fuel, and I think a slight tweak and we'll get her. But yeah, stay tuned for the dedicated video to this saw. We're really going to give it a good run through. And today, I'm actually pretty happy with the results. And believe it or not, she is not all that high in compression. I got a compression release on it, and I don't even use it. So even after all that machine work, the compression did come out really high. I think either it's the ring not seated or something else. I mean, it's going to come up a decent amount once the ring seats, but even after all that machine work, the compression isn't crazy. I mean, she might be sitting at 200 pound, but she's not like a 250 pound pole, you know what I mean? So, you know what I mean. But anyway, I hope you enjoyed this. We'll catch you in the next one. Later.